Hello all and welcome to December's CRC Cafe meeting. My name is Alex Carver. I'm a master's student in Jim Faust lab studying the factors that affect adventitious root formation of cannabis. Today I'm going to be going over some exploratory experiments that I completed with a group of undergraduates this semester on the effects of temperature and time of storage on unrooted cannabis cuttings and their performance in propagation. This experiment was inspired by some previous work done by Amy Enfield in Dr. Faust's lab on the influence of the post-harvest environment on cutting performance. She took a look at herbaceous ornamentals such as poinsettias. But what's important here is that a lot of these ornamental cuttings are coming from South America. And so for transoceanic transport, that requires sometimes up to 7 days before they reach their final destination. These cuttings are kept at about 10 degrees Celsius, and this is typical for your chilling sensitive varieties, but it also accommodates for varieties that are not sensitive to those colder temperatures. Improper packaging and handling can lead to a buildup of ethylene and CO2. This, therefore, can affect the final health of the cutting when it arrives at its destination. And what's also important here to take away from her dissertation was that temperature affects the potential storage time or storage duration of unrooted cuttings. Previously, there was a lot of work done on the post-harvest environments of vegetables and fruits and how that influences the potential for storage duration. But this was kind of the first that took a look at the post-harvest environment for rooting performance of these cuttings during shipment. And so carbohydrate status of the cutting is important because it influences or affects the root formation and propagation. And so we're trying to maintain that carbohydrate status through the time of transportation. Respiration is that process that breaks down these carbohydrates and starches to release carbon dioxide and water. But what Amy also showed was that it releases heat inside of a closed container. And so when we're moving or storing these cuttings at cooler temperatures, we're also trying to reduce these respiration rates. Now, ethylene is another important factor because it is a gas produced in response to stress. So when we go in and we take that cutting, the cutting will produce wound-induced ethylene. But these cuttings can also be exposed to external sources of ethylene, such as ripening fruits, exhaust, or cigarette smoke. Ethylene leads to the degradation of proteins and chlorophyll and can cause leaf senescence. From Amy's work, she was able to determine that cooler temperatures or cuttings stored at cooler temperatures produced less ethylene in storage. And so for our exploratory experiment, we designed a 3x3 factorial of 3 different storage periods of 3, 6, and 9 days. These cuttings were kept at temperatures of 2, 10, or 21 degrees Celsius. We placed 18 sunset cuttings in a gallon Ziploc baggie. This baggie had 9 holes pierced through the bag to allow for some gas exchange. And there was also a moist paper towel placed inside the baggie to prevent wilting of the cuttings. It's also important to note that these cuttings were kept in dark. The storage containers or the storage areas were all dark areas. They were not stored or were not exposed to high light. We kept notes on qualitative data at the time of planting and 24 hours after planting. We also recorded the fresh root weight and fresh shoot weight of the cuttings after 14 days in propagation. And so from 3 and 6 days, we never really saw a difference in cutting health at time of planting. So they all looked relatively the same. It wasn't until after 9 days in storage that we finally saw some stress. And that was the cuttings that were stored for 9 days at 21 degrees Celsius. We saw some chlorosis and wilting. And so those are going to be the cuttings that are on the far right side. You can see this is at time of planting. Your 21 degrees Celsius cuttings are chlorotic. They don't look as healthy as the cuttings that were stored for 9 days at 2 or 10 degrees Celsius. After 14 days in propagation, we also didn't really see a lot of difference in the storage time periods of 3 and 6 days. Once again, we saw some inconsistencies at 9 days of storage. And so you'll see on the left, you have your 2 degrees storage temperature for 9 days. In the middle, your 10 degrees storage temperature for 9 days. And then that far right is going to be your 21 degrees for 9 days. We saw inconsistencies where we have some cuttings that are rooting really well, but then we had some that did not root at all. So we saw that the warmer storage temperatures were affecting our rooting percentages. And this again is another shot of a 6-pack that was the cuttings stored for 9 days at 21 degrees Celsius. So those cuttings that were stressed at time of planting were more susceptible to some fungus growing up in there. So we again did not see a consistent, we saw more inconsistencies in rooting and cutting health at the warmer temperatures of 21 degrees Celsius for 9 days. Taking a look at our rooting percentages after 14 days in propagation, we had our control that was planted. That is this black bar. Those were cuttings that were planted immediately after harvesting from the stock plant. After 3 days in storage, we still had all of our cuttings producing roots at 100%. Where we saw some inconsistencies in rooting percentages is going to be again at 6 days in storage. And then at 9 days in storage, surprisingly enough, both at 2 and 10 degrees Celsius, we had 100% rooting. But at 9 days at 21 degrees Celsius, that gave us our lowest rooting percentage at about 80%. But that was, again, the cuttings that showed stress at time of planting and then were more susceptible to fungus. Taking a look at our fresh shoot weight, our control produced really one of the greatest shoot weights. Again, this is the cuttings. These are the cuttings that were planted directly after harvesting from the stock plant. It's surprising that 3 and 6 days in storage had both the lowest fresh root weights, but also if you go back to our rooting percentages, at least after 3 days in storage, we still had 100% rooting. It's just producing less roots than the control. And what really surprised us here is that after 9 days in storage, we do have these really high root weights, again, fresh root weights, even though we saw some inconsistencies in rooting percentages. So it showed a great drop in fresh root weight after 3 and 6 days, but then we saw that upward trend again after 9 days in storage. And so from conclusion of this experiment, we were able to determine that cuttings stored at warmer temperatures for longer periods of time were stressed at the time of planting and therefore did not perform well in propagation. Cuttings that were planted the same day that they were harvested had 100% rooting, and they also had a greater fresh root weight. Cuttings stored for 9 days did produce a greater fresh root weight, surprisingly, but only had 100% rooting when stored at 2 and 10 degrees Celsius. Again, the cuttings that were stored for 9 days at 21 degrees Celsius were stressed and did not perform well. But what we need to do for the further experiments is we need to repeat this experiment with some other varieties, get our numbers up there. Again, this was just an exploratory experiment, so we only had 18 cuttings per treatment. And so it'll be interesting to see if we can confirm that these trends are consistent with greater numbers. Also taking a look maybe at the packaging density of these cuttings. There were only 18 cuttings per Ziploc bag. So again, if we are packing in more cuttings into that Ziploc bag, are we going to see more stress or see stress sooner than 9 days in storage? So that is all still to be determined. If you have any questions, you can contact us at any of our emails, and we'll be happy to get back to you. I hope you guys have a wonderful holiday season and safe travels if you're going to go visit family. I look forward to seeing what we can bring to the table in 2023. Thanks.